Hello, everyone. Today we're going to solve the LeetCode question, valid parentheses. This is a very interesting, kind of fun question. It can be very tough at first if you don't know the data structure to use, but there's kind of a trick to it. For this question in particular, we're going to use the stack data structure. So for this video, I'm going to go ahead and teach how to use a stack, or like what is a stack, how to use a stack, and then also how to incorporate it into this problem to solve the problem. So let's go ahead and actually let me preface this video by saying, unfortunately, yesterday I had a very bad stomach bug. So at the moment, I'm not feeling too great. So I do apologize if at any point I sound a little bit off. That's just because I wasn't feeling too well, but I want to be productive. So went ahead and decided to make this video. Let's go ahead and get started. So given a string of braces, so it can have any combination of these 6 braces. So notice it's going to have the parentheses brace, the curly brace, and then the brackets brace. So the left and right combination. So there's 6 possible characters. And what we want to do is we want to check, are there valid parentheses? Are there always matching partners? You can think of it this way. So open brackets must be closed by the same type of brackets, and open brackets must be closed in the correct order. This sentence right here is what's critical. We'll look at some test cases below, and then I'll add some additional test cases so that you feel comfortable with what it's asking. Just because when I looked at these test cases, I feel like it didn't necessarily do a good job of kind of showing the true way of going about it. There should have been like an additional test case that we'll cover in a bit. So here we could see that obviously there's matching parentheses, right? So we have our left parentheses, and then we have the matching right parentheses. And it should be noted that we want it in this order. We first want the left parentheses, and then we want the right parentheses to match it. We don't want it to be in opposite direction. So for example, this would not be valid. If I start with the right parentheses, and then I have the left parentheses, yes, there's a complete set, but this is incorrect. Okay, so we'll discuss that in a moment. So notice here, I have the left parentheses, matching right, looks good. So these are partnered up. I don't have to consider them anymore. I have this left bracket, I have the matching right bracket. These are partnered up, so I don't have to consider them. And then the left curly brace matched with the right curly brace. So all of these matched. This looks perfect. Everything's good to go. Here I have the left bracket. That looks good. Left parentheses. And then I have a right bracket. Since these do not have the same type of brace, essentially, this is going to be false right here. So this does not work out. I also want to show an additional test case, which shows what would be valid. So number 1, we always have to start with the left brace. Just if you automatically start with any kind of right brace, so like let's say you start with the right bracket, the right curly brace, or the right parentheses, it's wrong. And that's because, once again, we want the left brace first, and then the corresponding matching right brace. So anything like this is wrong. So start with the right brace is always wrong, always incorrect. Right, so we would return false in this instance. So this is taken in that string, we would return false. Now, next up is, let's consider a more complex scenario. So let's say I start with the left parentheses, and then I have the right bracket, and then I have the right curly brace, and then the right bracket. Notice this. So what we have is this left parentheses, this left curly brace, and this left bracket. Let's see if they match in order and if they have the correct partners. Well, what's the last thing I added to this list? It's going to be this left bracket. So the first thing I should see if I do want to close this up, I have to see the right bracket, okay? Which I do. So you could think of this as cleaning this up, right? So you could think of, since these have partners, I can go ahead and just remove that instance. So here it's essentially down to here, this curly brace, and that's pretty much it. So we just remove that partner set. Now, the next thing I see here is going to be that right curly brace. And it matches with the closest, the last thing that I entered into this stack, which is called the left curly brace. So since this is a matching partner, I can go ahead and get rid of those. Then all I'm left with is, as partners, are these parentheses. So this left parentheses better be closed with the right parentheses. It is. So this is a matching case. So this is true, right? So this is valid. So you can kind of see how we're using the stack a little bit. It'll make more sense if you're not familiar with the stack. We'll go through that example in just a sec. But this is another valid test case that I wanted to show. Now, if we have non-matching braces, I think we've already considered that. Actually, this is already considered as a non-matching brace. So I can just kind of copy this over. Don't really have to put an example like that there. So this is a non-matching brace. But kind of going back to this idea of matching the braces. So whenever you see a match that's in the right order, that has the right type, you can go ahead and get rid of it. And it essentially what you're left with at the end is nothing, right? So if you kind of have this partner system, if you're left with nothing, then you know it's valid. You know it's true. It's a valid set of parentheses. So that's why this kind of focuses on all braces should be matched up and according to the algorithm. And so when it's complete, you have an empty stack, right? So let's go ahead and look at what a stack is. So in this case, we're going to include the stack for here, and we're going to create our stack. So a stack is it's like a template data structure. So what we're going to do is we're going to use the keyword stack. We're going to have, we can put anything in there because it's a template, integers, strings, and so forth. So let's just use a set of numbers. And the methods that we have available to a stack are going to vary. So number one, if I want to add numbers to my stack, I'm going to push a given value, right? So in this case, I can add to the stack. If I want to remove from the stack, I want to pop from the stack. So I want to remove from the top of the stack. And this will make more sense when I use the book analogy in just a sec. Next up is if I want to check if this is empty, I can use the empty method, and this will tell me if it's empty, tell me if it's empty. So this will just return a Boolean, true, it's empty, false, it's not. Next up is size. This will tell me the number of elements within my stack. And last up is going to be top. Top's important because what it'll do is it'll let you, so sometimes it's called peak, depends on what kind of data structure you're using, or depending on how it's implemented, top, peak, yeah, so stacks can be implemented a little differently, but it just tells you the value, the element, I should say, element at the top of the stack. Now, this only works if you actually still have stuff in the stack. If you don't have anything in the stack, this can lead to errors. So make sure that first you check that it's not empty. And then if it's not empty, you can get something at the top. It's the same thing as if you were to have like an empty vector, and then you want to grab the first element of that vector. Well, it's not really going to work. You're going to end up with a seg fault because you're accessing memory that's not yours. That's undefined behavior. So just something to keep on the lookout for this. Now, let's go ahead and add numbers to our stack. So let's say I want to push the value 5. Then I want to push. So what happens actually when we push a number onto the stack? Well, I want you to think of it like a stack of books. So this is the very bottom level of the stack. Whenever you push something onto it, you're putting it right at the bottom. So think of a book of stacks or stack of books. You're going to put it right at the bottom. Then if you were to put another book onto that stack, say I want to push the number 6, that's going to go right on top, right? So you don't normally pick up the first book and then put the second book right at the bottom. You just put it right at the top of the stack, right? Especially if you have 1,000 books. You're not going to, let's just say if you have 1,000 books, you're not going to pick up all 1,000 books and then put the newest one right at the bottom, and right? You're going to just put it right at the top where it's most convenient. Physics aside, right? So next up, let's say I want to push another number, like let's say numbers.push, let's say 2, and then numbers.push, let's say 3, and then numbers.push 9. Yeah, that should be good. So what we're going to do is we're going to add these values in the order in which they came. So 5, 6, 2 came up next in our stack. Next up is 3, and then lastly is 9. Also want to mention, if you already feel comfortable with stacks, you're welcome to skip to the solution. This is just more so for individuals that aren't that necessarily familiar with stacks. So it's just kind of a good lesson to throw in here. And I figured since this is a problem that uses stacks, it's a good way to kind of show how they work. So here's our stack, our set of values. We know that there's 5 values inside of here. And so if I wanted to print out the size, right? So if I wanted to print out the size of my stack, you'll notice that it's going to print out the value 5, just because that's how many numbers I have in my stack. If I print out the number that's at the top of my stack, what number is at the top of my stack? It's going to be the number 9. So if I print out top, notice it's going to give me the number 9. Perfect. Now, what if hypothetically, I were to first remove right? Let's say if I were to pop a value off of this stack, what's going to get popped off? Well, this is what's known as a LIFO data structure. So what that means is the last element, right? The last element added, last element in is the first out, right? So the last in is the first out. So that's what LIFO refers to. Last in, first out. So the last element in is the first one out. So if I were to remove something from the stack, I can't start removing things from the bottom. Just think of a stack of books that's 1,000 books high up. You cannot remove the one at the bottom, cannot remove the one at the middle, right? Think of it as a very unstable structure. What you do is you just remove the one at the top. So if I were to first remove the one at the top, so pop takes no arguments because it's going to remove the one at the top. This is really going to remove 9. So really our stack is going to look like this now. And if I print out the one that's at the top, that's going to be the value 3. So if we run that, you'll see that it's going to print the value 3. And that's really all there is to it. I don't think that there's anything else. Oh, there's empty, right? So let's just look at empty. So in this case, I'm going to go ahead and print out whether my stack is empty. So we already know that there's values in here, right? There's these 5 values. So it's going to say false because it's not empty. It has actual numbers inside of there. So let me put that 9 back on the top. So you might be asking, how do we iterate through these values? Well, the way you iterate through them is backwards. So you could do 9, 3, 2, 6, 5. And the way you do it, the way to think about it is like this. You look at the value that's at the top, which is 9, and then you remove it. So let's see the corresponding methods that are called. So what you want to do is you want to call what value is at the top, and then you want to pop it off. And then you repeat this. What's the next number at the top? It's going to be 3. There we go. 3. And then you're going to pop it off. Let's just do one more, just so we're clear on this. Then you're going to look at the next number that's at the top. So what's after 3? It's going to be 2. And then you're going to pop that off. And you can see how if we repeat this for the size of my structure, so since there's 5 in total, it'll eventually print out the list, but backwards. So 9, 3, 2, 6, 5. So let's go ahead and practice that. What we're going to do is we need to know the size right off the bat. So here, this is going to be my size of stack. And that's going to be numbers.size. Okay, it's good so far. Now what we're going to do is we're going to iterate that many times. So in this case, it's 5. So I want to iterate this 5 times. So what we're going to do is we're going to have our trusty, for loop. And we're going to say while it's less than the size of the stack. Size of stack. What we want to do is we want to iterate, right? So this is going to iterate 5 times for this example. Okay. Now, what we want to do is do that same structure. Number 1, we're going to print the value at the top of the stack. So how do we do that? We're going to print out numbers.top. And then we want to remove the value at the top of the stack. And this, since we already have the size, this is going to continue until the list is eventually empty. So we're going to have numbers dot pop. There we go. And so we'll go ahead and run this, and you'll see that actually, let's put them on separate lines so it looks like the stack that we wrote earlier. So you can see that this models the stack from earlier. So I hope that makes sense. That's just kind of our example on using stacks. Definitely recommend kind of just practicing it a little bit just to see what that's like. So going back to this idea of using stacks, let's look at that example. The left parentheses, I think it was left parentheses, right brace, and then left curly brace. So the way that we make this work is we're going to have a stack, not of numbers. So we don't want there to be numbers in our stack. What we want is we want to iterate through this string 1 brace at a time. And we're going to keep track of all the left braces. So we want to keep track of all the left braces. So let's say, what's the first thing that gets entered? The left brace. Okay, so let's enter that into our stack. The next thing that gets entered is the right brace, right? So let's go ahead and add that into our stack. Right bracket, I should say. The next thing that gets entered is this left curly brace. So here's the left curly brace. Okay, looks good. Although it's a little bit different once we get into the right braces. So the right braces of any kind, which are these three possible, what we want to do is we want to check that, so in this case, this right curly brace, is that it matches whatever's at the top. So the last brace, the last left brace that came in, better match the first right brace that we're seeing. So in this case, I do see that there's a match, right? This right brace gets matched with this left brace. So what I can do is, if there's a match, which there is, we're going to delete the match because we've already found its partner. So right there, happy couple, they can go ahead and leave to their new home, I guess. So next up, now we're on here. So this is the right brace, and we have to check that this right bracket matches what's at the top of our stack. Does it match? Yeah, it looks like it does. So because it does match, what we're going to do is we're going to have that be its partner. We're going to remove it from the stack. And then once again, here we have this right brace, right parentheses. It does match what's at the top of the stack, and we're done, just like that. So it looks pretty good. All right, so there's no issue. That's the matching case. What if, let's say, for example, I had the wrong type, right? So let's put the left braces again. So right parentheses, right curly brace, right bracket, right curly brace. And the first thing that you see is the right bracket. Well, the right bracket does not match this left brace. So as if there's a mismatch, if the right brace is a mismatch, or I don't know if I spelled that wrong, mismatch with the top of the stack, then it's false, right? So we know we didn't find a partner for it. It's kind of a issue within that romance. So that's going to be wrong. We return false. So that's one simple case. Now let's look at actually, one thing I forgot to mention about the last case is if we did have matches, do you remember how we were able to match everything up and delete everything from the stack? If it's empty at the end, that means they all had partners, had suitable partners, and it's true, right? So that was a valid set. Okay, so pretty straightforward enough. Let's look at the last case. The last case is, what if you start with the right brace? Well, if you start with the right brace of any kind, you don't add it to the stack. What you do is you check at the top if there's anything. But this is where I told you to be careful, just because you can't, there's nothing at the top here, right? This stack is so empty. So what we do is we say, if you initially start with the right brace, it's a wrap. There's no, it's going to be false, right? So that's an invalid case. I guess the same thing would happen if you have only a single left brace. If you have a single left brace, well, that's it. So once you're done with your algorithm, you notice that it's not empty. So this guy didn't find his match. And so just like that, it's false, right? So that's pretty much the idea behind this algorithm. I definitely recommend watching or reviewing the previous sections if you have any questions, just because it's very important to understand the problem before you tackle it. So what we're going to do is we're going to go ahead and solve this problem. Let's solve it here. Yeah. So what we want to do is we want to create a stack of braces. It's really going to be left braces, but I'll just call them braces. So what we want is we want a stack of characters, which are going to be the individual braces, just like that. And what we want to do is we want to iterate through each brace, right? So we want to iterate through each brace for the stack S. So iterate through each brace from the string input. The next thing we want to do is we kind of want to consider the case where there's a right brace right off the bat, because that's going to be an invalid scenario. So let's check if it's a right brace. The way that we do that is to keep things a little bit cleaner, I'm going to go ahead and set a Boolean for that. So a right brace is if the brace matches right, is a right curly brace, or the brace is a right parentheses, or if the brace is equal to Let's see. So what's the one I forgot? It's going to be the bracket. There we go. So if a brace is either one of these options, then we know that it's true. Right. Or sorry, if a brace is either one of these options, then we know it's a right brace. Right. Next up, what we want to do is we want to check if our stack is empty. If our stack is empty, so we haven't added any left braces. If our stack is empty and we have a right brace, then we know we can return false right off the bat. So let's go ahead and just comment that. So if we have a right brace and it's the first brace we encounter. So we start off with any right brace, it's a right. Next up is going to be if we have a left brace. If our brace is a left brace, so if our brace is the right parentheses, this, actually, I'm just going to go ahead and copy it from here. So because we understand if it's a left brace. So if it's a left brace, then what we want to do is we want to add it to our stack, right? We want to add it to our braces stack. So we're going to push that onto our stack, whatever the current brace is. So push the current brace onto our stack, And of course, I want to make this a comment. And what we want to do is we just want to continue. So that's it. For a left brace, it's just as simple as just pushing it on the stack. We don't want to kind of concern ourselves with any other action. Left braces are really simple. The next thing is, what if now we see a right brace and it's not the first time? So we've already considered that when it's a right brace and it's the first time. But what if it's not the first time? We have to check if the right brace is a matching condition. And so what do I mean by that? What I mean by that is an example could be that, let's say I spot the right brace, right? Or let's say the top of the stack is a left parentheses. I also want the new brace to be a right parentheses. I want it to be a match. So that's an example of a matching condition. So we could do this, we could replace this with brackets, and we could also replace this with curly braces. So if it's any of the matching conditions. So I'm just going to copy this over, otherwise it's going to take a little bit of extra time to print that out. There we go. So if we have any of these matching conditions, then we're good. We're going to be able to pair them off. So if I match in the first case, or I match in the second case, or I match in the third case, then I know I found a happy couple, and we can go ahead and push off of this braces, the one that was at the top. So I'm going to go ahead and say braces pop, sorry, not push, pop. I'm going to go ahead and remove the matching left brace. There we go. So this is the instance where we have a match. We have a match. And so that's good. We want to keep popping. We want to keep popping throughout this for loop. But what if we didn't find a match? What if it was wrongly paired? What should it be in that case? Well, if it's wrongly paired, we know that we have an issue. It's not valid. It's not a valid set from matching parentheses. So there we can immediately return false as well. Now, once this loop is done, ideally, so what will happen is it'll find all the matches until we're left with nothing. So ideally, if we are left with nothing, we know that it was valid. So what we do is we say, is it empty? So did we get it to be empty? So we're going to check if our braces are now empty, or if we have nothing in our left brace stack. If it is empty, we're going to go ahead and return true. Right. So we're going to go ahead and return whatever the status is. So if it's empty, if the stack is now empty, then we know it was a match, was a matching or a valid friends set. And if this is false, it's not empty, then we know we can go ahead and then we know it's false. So we know that this is not valid, right? We had some kind of partner left over. And that example could be like if I only had a single left brace, right? We're gonna have a partner left over. So I hope that made sense. I want to go ahead and actually just run this to see if I don't make any typos. Okay, perfect. So this looks good. So I hope that that made sense. Please let me know if you had any questions. I try to do my best to kind of do a comprehensive overview of the stack and also really kind of explain this problem just because it can be tricky, especially if you try to do it iteratively, right, with like some kind of loops. Using the data structure of a stack is just a good fit for this problem. And so that's why it's important to learn data structures, just because you have different ways of solving certain problems. So thank you so much for watching. If you enjoyed the video, I strongly recommend please like, sharing, and subscribing so you can see more solutions to these LeetCode problems. Thank you so much, and I hope to see you soon.